Hi, my name is Chelsea and I'm with the Los Angeles Maritime Institute, and today I'm going to talk with you about physics of sailing. Yeah, so if you look at any sailboat, you will see that there are some big upright bits called the mast, and then attached to that is a big piece of cloth, a sail. And when the wind is blowing, the sail will fill with air and belly out, make a nice round shape, and the boat will begin to move forward.
The cool thing about sailboats is that you are not limited to go just with the wind. Depending on the type of sailboat you have, you can actually point towards where the wind is coming from. The only place you cannot go is directly into the wind.
This is because of the physics principles defined by Bernoulli and the concept of lift. So, why does a curveball curve? Why does an airplane fly? How does a sailboat go? The answer is all the same. Bernoulli's principle states that the faster a fluid moves, the less pressure it exerts. Fluid, we were just talking about air and wind. Well, something to keep in mind is that in physics, air and liquid act similarly enough that they can be treated the same way mathematically and are together referred to as fluids. As a ball, a wing, or a sail passes through the air encounters the object with different velocities and therefore different pressures. If we look at this drawing of the boat, we see that there is a curve to the sail. As the air flows across the boat, the air is cut in half by the sail. The air is going to travel at the same speed. However, when the wind splits on either side of the sail, the air on the outside of the curve, or the leeward side, is going to move faster in order to continue traveling because it has further distance to travel. This spreads the molecules of the air apart and creates a low pressure area on that side of the sail. The air on the windward side is going along the belly of the sail, and it's going to move slower because it doesn't have to go as far. So this air is more dense and exerts a higher pressure on the sail. This high pressure wants to move to the area of low pressure, which drives the sail in that direction. The result of this difference in air pressure is a net upward force called lift. Now you may wonder, how come the boat doesn't fall over? The answer is because of the keel and Newtonian physics, specifically Newton's third law, that for every action there is an opposite and equal reaction. As the boat is pushed by the wind, the water pushes back against the keel below the waterline, and that is enough force that the pressures of the wind and water nearly cancel each other out, and all that's left is that forward motion from the lift. And that is a brief introduction into sail theory. Check out our other lessons and more cool stuff coming up, or better yet, come sailing with us out on the boat and experience this physics for yourself.